and welcome back to class. So today we're going to learn a little bit about something called statistical inferences. So to start off, we're going to learn about the definitions of statistical inference and estimation. So statistical inference is where you look at a set of data to make assumptions of the general population. So looking at data for making assumptions of the population. So in doing that, we tend to make something called estimations, which in math, it is just like an estimate in real world. It is a general guess based on evidence. A general guess based on evidence. So this evidence can be data, it can be someone telling you something, but this evidence leads you to make a general guess. So when looking at estimations, we can use our basic number sense skills to correctly make estimations of what the whole population would look like. So we're going to go over this problem here. It says Alice took a random sample from her 7th grade team of 76 students about how much time they spend on their phones a day. She took a sample of 30 students. She recorded her findings on the table to the left. So at the table to the left, we can see that she has a column saying time spent on phone and another column saying number of students. So, out of her population of 76 students, she took a sample of 30 students. So, these students and the number of students are 30 student sample. So, this question asks, what would it be an accurate estimation of how many students spend less than 1 hour on their phone out of the entire population? So we are seeing here that it says less than 1 hour. So we're going to go to our table and find where it says less than 1 hour. And we can see that 6 people say that they use less than 1 hour on their phone a day. So that means we are going to have 6 students out of those 30. And now we look and notice that there are 76 students total, where 76 is a little more than double 30. So if our data set of number of students, we should see that a little more than double of our students are going to be spending less than 1 hour on the phone. So a little more than double of 6. So 6 times 2, doubling 6 is 12. So the number closest to our 12, so a little over the 12, is this 15. So we're going to get the answer C. It would not make sense for A to be correct because that means our sample of 30 students had all students who spent less than 1 hour a day on their phone in that group. The same thing with 72, that is super duper close to 76. So even if we added up the other students that are on this chart and say every single other student in the classroom spends less than an hour that were not sampled, we would still have more than the 76 needed if D was correct. So that leaves us with B and C, and just using that sense of, okay, we have 30 students, that's a little less than half of how many we have, we can conclude that 15, or C, is going to be our correct answer. So we want to use the same kind of logic for seeing the next question. This next question asks, what would be an accurate estimate of how many students spend 3 to 4 hours on their phone out of the entire population? So again, we're looking 3 to 4 hours, and we're going to go to our table and see here's 3 to 4, and that we see 9 out of those 30 students said that they spend 3 to 4 hours on their phone. So this time we're going to start by looking at our answers, and we can automatically say that C is not correct because that is less than 9. Anything less than 9 would be saying that if we asked every single one of those 76 students, less people would say they spend as much time on their phone than if we interviewed 30. So it doesn't make sense. As we continue looking, we can go ahead and assume that 52, or A, would also not be quite right because it is too large of a number when you're thinking about how close 9 is to 30 compared to 52 is to 76. It doesn't seem to add up correctly. So now we're left with looking at B, 23, or D, 17. So we're going to start using our number sense again. We know that 30 is less than half, just small, tiny bit less than half than 76. So we have to ask ourselves, is 23 or is 17 double 9? A little bit more. So we know that 9 doubled, so 9 times 2, is going to give us 18. So is 23 or 17 a little more than 18? Well, 17 is less than 18, so we're going to say no to that one. And we can see that 23 is a little bit more than 18. So we're going to go with B, 23, as the accurate estimation, as close as we can get using this process, for how many students spend 3 to 4 hours on their phone. So we're going to go ahead and move on. Another way of looking at estimations and statistical inferences is by using proportions. So this question says that a tiger rescue tagged 74 tigers in the wild to try to find the amount of tigers that are in the wild. So they later saw a group of 39 tigers where 18 were tagged. So in that group of 39 tigers, only 18 of them had been tagged already. So use this information to create an estimation on how many tigers are untagged in the wild. So we want a estimation using proportions, and we are going to say how many are tagged over how many are untagged. So we need to find out how many are tagged and untagged in that group of tigers that we saw. So it already says that there are 18 of those tigers were tagged. So we can put 18 in for that T here. Now we had 39 tigers total. So to find out how many were not tagged, we can do 39 minus 18, which is going to give us that 21. So we have 21 untagged tigers, because that is how many tigers were left. So now we are going to use a proportion to try to estimate how many untagged tigers there are in the wild. So again, we're going to do tagged over untagged, and we can see here that it says there are 74 tigers in the wild that they tagged. So we can say there are 74, but it doesn't tell us how many are untagged. So this untagged, we are looking for it. So we are looking how many there are. So this U for untagged is going to stay the same. Now the thing about proportions and estimations is we want to try to get them as equal as possible. So we're going to go ahead and set this up to each other. So 18 over 21 is going to equal 74 over U. U stands for our untagged. So now we're going to solve this like proportions. And when you do that, you want to cross multiply. So we're going to multiply 18 by U, which is going to get us 18u, where u is our variable. And then we want to do 74 times 21. That's going to get us a large number of 1,554. Now we look at this and we see that we can't multiply 18 by u because we don't know yet what u is. So we need to undo what is happening to that u. So when we ask ourselves what's going on, we can see that 18 is multiplying that u. So to undo multiplication, we need to do division. So we're going to divide 18u by 18, but we need to keep these equal to each other. So we need to divide both sides by 18. When you divide 18 by 18, you're just going to get 1. So it's just going to leave us u because 1 times u is u. So 1,554 divided by 18 is going to give us approximately 86.3. And because we're talking about tigers and we can't have a third of a tiger, we're going to round, and that rounds to 86. So we are saying that the tiger rescue were unable to tag 86 of our tigers that are in the wild. So we tagged 74 and there are 86 that were not tagged. And using that information, you can find out how many tigers there are in the population, in the wild in general, but it's just asking us for untagged. So the next problem is about a beach and how many people are expected to go. It says Carteret County is trying to prepare for the summer beach season. To try to find out how many tourists are planning to come to the beach, Carteret County sends out a survey asking people if they're thinking to go to the beach over the summer to 3,685 people. Of the amount of people the survey was sent to, only 593 responded. So Carteret County created a table to show the survey responses to the left. Use proportions to find the estimates below. So we have 3 questions that are asking us to find the estimates of who will be going, who are thinking about, and who are planning on not going to the beach. So I want you to pause here and give this a try. So if you've hit play, I assume you have given this your best shot, and we are going to go ahead and work through them together if you'd like to follow along. So the first question asks us how many people can Carteret County estimate will be going to the beach. So we need to think about how many people responded saying they are going to the beach for this first question. And it says there are 186 people going. So there are people going is 186. And this is going to be over how many people responded to the survey. So we're going to use R for that. So again, the question itself, the information it gave us, said that 593 responded. So now that we have our proportion for how many people said they were going to the beach out of how many people responded, we're going to set this proportion equal to how many people we think are going to go. So that's going to be G because we don't know that yet. And that's what we're trying to find out. To how many people we sent out and asked in general. And we asked 3,685 people. So now we are going to solve for G. We're going to do this by cross multiplying. So we're going to get 593 G. And it's going to be equal to 186 times 3,685. Which gives us a really large number of 685,410. And we want to undo what's happening to this G, which is multiplication. So we're going to divide. So 593 on both sides. And when we do that, this 593 crosses out, leaving us with G. And we're going to divide that 685,410 by 593. And when we do that, we get a large number of 1,155.8. So then we have to ask ourselves, can we have 0.8 of a person? The answer is no. So we're going to round to say that we can estimate that 1,156 people are going to the beach out of all the people we asked. So this next question asks us, how many people can Carteret County estimate are thinking of going to the beach? So we can look to our survey responses and see that 256 people said that they're thinking of going to the beach. Haven't decided yet or not. So again, we are going to set a proportion of how many people are thinking over how many responded. This gives us 256 people are thinking of going. And just like before, we have 593 people who responded. I'm going to set that equal to how many people out of our total are thinking of going, which we don't know, so we're going to use T. And how many people we asked in total, which was 3,685. So now we're going to cross multiply just like before. 593 times T is going to be set equal to 256 times 3,685, which is 943,360. So we need to get this T by itself. So we're going to divide both sides by 593. That's going to leave us with T equals that 943,360 divided by 593, which again is a really large number of 1,590.8, which we can round to 1,591 people are thinking of going to the beach out of that 3,685. So our last question asks us, how many people can Carteret County estimate are not going to the beach? So out of all the people we asked, how many of them are not going to go to the beach? So it says on our survey response table that 151 people said they are not going. This is our not going. Over how many people responded? So not going is 151. How many responded is 593. And we're going to set that equal to the total. So we don't know the total yet of how many people aren't going, but we do know we asked 3,685 people. So just like the times before, we're going to cross multiply these. 593 in is equal to 151 times 3,685, which gives us 556,435. We're going to divide both sides by 593. And we're going to get that N equals 556,435 divided by 593, which is going to give us 938.3, and we can't have 0.3 people, so we can round that to be 938. So Carteret can estimate that out of the people we asked, 938 of them are not going to be going. So I do hope at home you are following along, taking notes, and you're able to check over your work. And I hope that you are finding practice problems, going over this, and doing your work your teacher has given you. But I will see you next time. Bye!